Hello everyone, I'm Akash. In today's video, we will solve very interesting question from TIFR 2021 exam. Question is on linear algebra and it is a true false type question. The statement for the true false type question is the real vector space Mn over R cannot be spanned by nilpotent matrices for any positive integer n. Is this a true statement? So let's find out. Let's suppose that the given statement is a true. So by given statement, let's suppose there exists positive integer, n such that Mn over R can be written as span of set S, where S is a set of nilpotent matrices, where S is a some set of nilpotent matrices, where Ni are nilpotent for every I. Okay. Now we know that identity matrix belongs to Mn over R. Okay. The identity matrix of size n by n belongs to Mn over R. Okay. So it can be written as linear combination of the vectors in S, because S span Mn over R and identity matrix belongs to Mn over R. So by definition of spanning set, identity matrix can be written as linear combination of the vectors in S. So this implies identity matrix can be written as A1 times N1 plus A2 times N2 plus up to so on AK times NK for some scalars A1 up to so on AK. Now, as the left hand side is the matrix, so right hand side is also a matrix, and these two matrices are equal, so their trace are also equal. So this implies trace of identity matrix is equals to trace of A1 N1 plus A2 N2 plus up to so on AK NK. Okay. And by properties of trace, we know that trace of matrix A plus B is equals to trace of A plus trace of B. Okay, where A and B are the square matrices of same size. And generalizing this, we have trace of A1 plus A2 up to so on AK is equals to trace of A1 plus trace of A2 plus up to so on trace of AK. So by that property, we have this can be written as trace of A1 N1 plus trace of A2 N2 plus up to so on trace of AK NK. Okay, it is clear. Now we also know that trace of scalar multiple of some matrix, okay, trace of Ka is nothing but equals to K times trace of A for any scalar K. Okay, so this can be written as trace of A1 times trace of N1 plus A2 times trace of N2 plus and so on AK times trace of NK. Okay, but we know that Ni are nilpotent matrices for every I, and we know by properties of nilpotent matrices that all eigenvalues of nilpotent matrices are 0. All eigenvalues of nilpotent matrix are 0, and we know the trace can be written as sum of eigenvalues, and as every eigenvalue of nilpotent matrix is 0, so trace of the nilpotent matrix is also 0. So we have A1 times 0 plus A2 times 0 plus and so on AK times 0. Okay. So this is equals to 0. So we get trace of identity matrix n cross n identity matrix is 0, which is contradiction. Okay. Since we know that the trace of n by n identity matrix is equals to n itself, and as n belongs to positive integer, so n not equals to 0. Okay. So this is a contradiction. So our supposition that there exists a positive integer n such that Mn over R is equals to the span of S, where S is a subset of nilpotent matrices, must be wrong. So we must have for every positive integer n, Mn over R cannot be equals to span of S, where S is a subset of nilpotent matrices. So the given statement is false. There is a small announcement that we are soon starting our new batch for TIFR 2025 exam. The batch will be online. For any type of inquiry, you can write us on following email ID. So if you found this video interesting and helpful, then please like and share this video and subscribe to our YouTube channel. Thank you for watching.